All right, welcome back to the deep dive. Today we're going deep on a particular section in the world of AI, artificial intelligence, and you shared some really interesting stuff with me, and we're gonna zero in on clause 10 of this ISO IEC 22989.2022, right?
Yeah.
And think of this as a kind of a guided tour through the actual applications of AI systems,
Yeah.
almost like we're going through a textbook, but in a fun way.
Right. Think of this deep dive as your structured learning experience for how AI is being implemented out there in the real world, specifically as it's laid out in this international standard. Our goal is to break down each of these applications. Sort of like, almost like a pair of instructors taking you through the concepts and giving you clear examples of how AI is actually being used.
Yeah, and just so everybody knows right up front, this entire deep dive is based on the information that's found in ISO IEC 22989.2022.
Right.
We're not bringing in any outside, opinions or examples.
Mm-hmm.
We're just sticking to what this document lays out. So with that framework in mind, let's get started. Clause 10 opens with kind of a general intro and kind of sets the stage for the specific applications that we're going to be looking at.
That's right. Section 10.1 is a brief but important preface. It tells us that this clause is dedicated to the concrete uses of AI systems.
Okay, so let's dive into the first specific area,
Okay.
which is 10.2, fraud detection.
Right.
The document starts by defining what it means by fraud in this context.
Yes.
Can you talk a little bit about that?
So fraud, as the document states, is basically using deception for gain.
Okay.
It's misleading somebody or some system for unfair personal or financial benefit.
And it sounds like this kind of deception can show up in a bunch of different areas of life.
Absolutely.
What are the specific areas that are called out in the ISO standard?
Well, the standard lists several areas. One is counterfeit money and documents.
Mm-hmm.
That's been around forever, and AI is being used to try and combat that. It also mentions stolen credit cards and documents, a concern for many. And then it calls out personal communications, particularly email,
Right.
and, scams like phishing.
Yeah.
And last, it addresses fake or stolen identities, which can be exploited for lots of bad stuff.
Yeah, no kidding. So those are the, sort of the battlegrounds.
Mm-hmm.
How is AI actually being used to detect fraud in these different areas? What are the specific applications that the document mentions?
It mentions several significant applications. One major one is the identification of fraudulent credit card charges. Here, AI algorithms look for anomalies that deviate from your typical spending habits.
Okay.
Things like unusual amounts, unusual locations, or a sudden spike in transactions.
Yeah, I've gotten those alerts from, my bank or my credit card company. Is this you?
Right.
And it sounds like it's probably AI that's kind of behind those safeguards.
Exactly.
What other fraud detection applications does the standard mention?
Another key one is identifying fraudulent loan or credit applications.
Okay.
In this case, AI analyzes the information provided in the applications, looking for inconsistencies that might suggest someone is trying to get credit using false information.
So it's not just about catching fraud after it's happened, but maybe even preventing it during the application process.
Exactly.
That's a really important point.
Yeah,
What about insurance? Does AI play a role there?
absolutely. The document also highlights the identification of fraudulent insurance claims. AI can analyze the details of claims, medical records, accident reports, looking for patterns that could indicate a claim is exaggerated or even totally made up.
Wow. Okay, and the last application for fraud detection that the standard mentions is identifying fraudulent account access.
Right.
How does AI tackle that?
This involves monitoring login attempts and overall account activity for any unusual behavior. AI can detect things like logins from unfamiliar locations at odd hours or a sudden bunch of unusual transactions, all of which could indicate that an account has been compromised.
It's really amazing to think about how many different aspects of potential fraud AI is being used for. When you think about it, so many of these areas, we encounter every day. Whether you're using a credit card, applying for a loan, just managing your online accounts, AI is working in the background to protect you and your transactions and your information. It's almost like this invisible security force.
Absolutely. It really highlights the crucial role AI is playing in protecting our financial well-being and our data in this digital age.
Yeah, for sure. All right, let's move on to a completely different area now. Section 10.3 of this clause focuses on automated vehicles,
Okay.
which is a topic that, gets a lot of people talking and a lot of excitement. What's the take on this from the ISO standard?
The clause takes us into this rapidly developing field of automated vehicles. It acknowledges the expectation that fully driverless cars could become commonplace on our roads.
Right.
The tone is forward-looking, recognizing this huge potential for change in how we think about transportation.
But it also grounds it in the present, right?
Yes, it also points out that a lot of AI-powered technologies are already in vehicles today as driver assist features.
Right.
Things like adaptive cruise control, lane keeping assist, automatic emergency braking. These are all examples of AI at work in vehicles right now.
Yeah, I mean, the idea of a fully autonomous car is still sort of, feels a little bit futuristic to a lot of people, but we are already seeing the beginnings of that technology in our cars.
Yeah.
What specific AI applications within vehicles does Clause 10 actually lay out for us?
The standard lists several. One is optimized routing, something many of us probably use every day with nav apps on our phones.
Yeah.
AI algorithms analyze real-time traffic conditions, road closures to find the fastest route.
Yeah. That's a lifesaver sometimes, for sure.
Absolutely. Another application is automated lane changing.
Okay.
This involves the vehicle using its sensors and AI to assess traffic and safely change lanes without any driver input.
That still sounds a little sci-fi to me, but I know the technology is moving really fast.
It is. Another critical application is object avoidance. Here, the vehicle uses cameras, LiDAR, that's that laser technology that creates a 3D map of the surroundings, and other sensors.
Right.
This data is processed by AI algorithms to detect objects in the vehicle's path, and the system can adjust the brakes, the throttle, the steering to avoid a collision.
Yeah, it's a really important safety feature.
Absolutely.
And we're seeing kind of early versions of this technology already. What's the final application that's listed?
The final one is fully automated point A to point B travel.
Okay.
This is where the vehicle can navigate and drive itself from start to finish without any human intervention.
The true driverless car experience.
Yeah.
It's interesting to see how these individual AI applications are like building blocks for that bigger goal of full autonomy. The document also mentions some of the core AI technologies that make this possible, right?
Yes, it specifically mentions computer vision and planning. Computer vision allows the car to visually perceive its surroundings, identify things like other vehicles, pedestrians, traffic signals, and then planning allows the AI to make decisions based on what it sees.
So it's really like a whole AI ecosystem operating within the vehicle.
It is.
Okay, let's move on to the last area discussed in this clause, which is predictive maintenance.
Yeah.
It's section 10.4. And, as the name implies, it sounds like a much more, forward-thinking approach to maintenance. How does the document introduce this concept?
It's presented as a more proactive strategy than traditional preventative maintenance, which relies on fixed schedules. Instead of just replacing parts after a set number of hours or months, you're constantly assessing their state and anticipating when they might need attention.
Okay. So how does AI fit into that?
AI algorithms analyze data from sensors and other systems. They can identify patterns that could indicate a failure long before it's detectable through traditional methods.
That sounds like it could lead to huge gains in efficiency and maybe even prevent really costly breakdowns.
Absolutely.
Can you give us some concrete examples of how AI is being applied in predictive maintenance, the kinds of things that the standard lists?
Sure. One example is the detection of voids or instabilities underneath railroad tracks.
Okay.
AI can analyze data from sensors to identify sections where the ground beneath the tracks is compromised. This allows for preventative repairs, reducing the risk of derailments.
Wow. That's a powerful example. What's another area where it's being used?
Another application is the detection of cracks or other damage in asphalt, on roads and airport runways.
Yeah.
AI systems can analyze images or data from sensors to find these issues early on. This allows for timely repairs, prevents small problems from becoming big ones.
Makes sense. You catch a small crack before it turns into a huge pothole.
Exactly.
What about in industrial settings?
Yes, the document mentions the detection of failing bearings in electric motors. AI can analyze data like vibration levels, temperature, even sound patterns to predict when a bearing might fail. This allows for proactive replacement during scheduled downtime, avoiding unexpected production stoppages.
Yeah, really crucial in those kinds of environments where downtime can cost a lot of money.
Absolutely.
What's one last example that the standard highlights?
The last example is the detection of abnormal power fluctuations in electrical supply systems. AI can analyze the data from the power grid to identify patterns that could indicate a potential component failure. This early detection can help prevent wider outages and ensure a more reliable power supply.
So when you look at these different examples of predictive maintenance, from keeping the trains running safely to preserving our roads and runways to keeping factories operating and keeping the lights on,
Hmm.
it's all about using data and AI to anticipate and prevent problems before they even happen.
Precisely. Think about the impact. Increased safety, reduced downtime, more efficient resource management. It's a smarter approach to ensuring the reliability of these essential systems.
So in this deep dive into Clause 10, we've seen how AI systems are actually being applied in these crucial areas:
Right.
fraud detection, automated vehicles, and predictive maintenance.
Yeah.
And each of these examples demonstrates the power of AI in the real world.
And again, this is all directly from the ISO standard, giving us the standardized view of these technologies and their applications.
So thinking about these applications, where else do you see potential for AI to make a big impact? Maybe in ways we're not even talking about yet. This document gives us a solid foundation, and it's clear that the future of AI is vast and it's still unfolding.
It is. It's a field that deserves a lot of attention and exploration.
For sure. All right, well, that's it for this deep dive. Thanks for joining us. We'll see you next time.